All right, so thank you for coming. I know it's Friday. I know it's been a long week. What I will try to do, I think we have two sessions. Is it too loud? Okay. We have two sessions, one following another with a 10-minute break. We will see if we need to take a break or we can go for about an hour and a half or so and complete everything. We'll see how that goes for the first hour. We spent a bit of time on, now I'm losing track of days, day for yesterday, I think, where we spoke about what GALE is, the overall product, what the product stack is, and we had different discussions on types of the use cases that you could apply GALE on. I want to give you a live preview of the product. So I did spend a good amount of time in the morning praying to the demo gods. Hopefully everything works. And I will, depending on how things go, I will also do something daring at the end of the session, if I can. First, let's see how the first few demos that I plan to goes. Just as a reminder, I think we spoke about what GALE is as a product. I think you probably, hopefully all of you guys were in the session when we spoke about this day for yesterday. And I talked about the entire process of building GenAI agents and how we are planning to accelerate that with a bunch of toolkits we have within the product. To remind you, the overall stack of the product itself, again, just a brief overview, that we start with the base, that's with your data, and then we have an entire product which has a bunch of different tools, starting from connectors that enables you to connect to various different data sources you have within your organization. That's the base, obviously, because when you start thinking about it from a perspective of building AI agents, you need to be able to get your enterprise data and work with it. Am I blocking your view on that side? Okay, because anyway, I'll sit in a bit. Then comes the foundational models. As I was talking about, we support quite a few of commercial models and everything that's new. We always test and put them back in. We support a significant amount of open source models, I think 30 plus right now, and we have a direct integration with Hugging Face, and we continue to improve those. There are two approaches we take there. One is test the open source models, that when they come in, we figure out, we apply that within our ecosystem, figure out which one makes sense, and then we host it. But of course, if you guys have done your own testing, and if you want to directly bring in Hugging Face, we enable that as well. The entire aspect of fine-tuning sits on top of it. This gives you the ability to take any foundational models, bring your own enterprise data, and then fine-tune that for the respective use cases and tasks that you're thinking about. This helps you for multiple perspectives. One, obviously, if you're thinking about cost, you fine-tune models can, especially open source models, can work out better in terms of cost effectiveness. Latency is going to be substantially better if you use smaller models. Accuracy and fine-tuning of the models specifically to what it needs to be done. The accuracy of those things increase comprehensively, and I'll show you a couple of examples of that as well today. So once the fine-tuning is done, and by the way, honestly, there are not every use case you need a fine-tuned model. There are use cases where you would need them, and for those use cases, you may want to think about it. But generally, most of the foundational model, commercial or otherwise, should suffice, and they should be able to do the job what they're supposed to do. On top of that sits the agents. We have a few different buckets within the agents. The prompt hub, the prompt engineering capabilities, where you can actually bring in multiple different models, experiment with one prompt and multiple prompts. And the prompt hub, we've been working on it. It's still not in the product, but I'll show you the bunch of prompts we've already categorized. The objective there is we've been identifying common use cases where typically people use GenAI models for, and we are designing the prompt that will get you the best response from the models. And what we are also doing alongside is we are identifying every prompt across which models they work better, and give you some kind of a recommendation as a good starting point for you to use them and see if those make sense when you start applying that for your use cases. Now, all of this is built on layers and layers of our experience of building the platform over the last decade. So which means that our ability to go from an experimentation stage to a scale to thousands of users is going to be extremely easy, because you've taken all of that behind in the platform, applied that as a foundation piece, and that is where LLM Ops comes into play. I also talked about saying the GALE being a part of the Kore family. We integrate with pretty much most of the core products that are appropriate for GALE. Search AI is one of the most important product that's going to be used with GALE in many, many workflows and use cases. Obviously, if you're looking at your enterprise documents and you're trying to bring that information and make that part of the flow, then definitely that would make sense, and we have a good integration with Search AI. We will introduce what we call a Search AI node within GALE. So once you have that, if you have Search AI as a product where you've ingested all your enterprise documents and you've created different groups of collections there, you can choose a collection and make that a part of the workflow within GALE. I'm going to touch upon a few pieces in here. I'm going to talk about the aspect of data connectors, API nodes, talk about the foundational models and commercial models, how we support them. Definitely, I'll show you some fine-tuned models. I'm not going to go through the process of fine-tuning. That's going to be substantially longer amount of time than what we have right now. But I will talk about some of the fine-tuned models, and I'll show you some examples of how the fine-tuned models have really enabled us to build flows specifically for certain type of use cases. Good point. I think one of the fundamental difference between the platform and GALE, we are kind of making this. It may seem like a very thin line, because you could think, when you think about GenAI models and GenAI agents, the common use cases people are thinking about is essentially chatbots. But we have a very clear differentiation, because our platform is built for conversational AI, and GALE is built for automation AI. Essentially, anything that does not require a back and forth with a customer or an agent, then you would want to go with GALE. When there is a reason where a customer is interacting with a bot and there is a back and forth happening, you would want to build something in the platform. That said, though, they both coexist. So for example, if you think about, let's say, a customer service for insurance scenario, if a customer comes in and says, I have an accident, I want to claim an insurance, and the conversation begins, and they send out an image of the accident saying, well, here is what happened. This is my car. This is the damage. You can have a GALE flow behind the scenes that takes that image, analyzes what's happened, identifies what the damage is, and comes back with a recommendation of saying this is the whole cost that's going to happen. Once you build that flow in GALE, you can integrate that with XO, and the conversation will continue after that. You will trigger GALE flow, GALE executes, the response comes back, and you can continue with the XO platform for conversational bot. Did that answer that question? Yes. Okay. Any other questions before we start? Yeah.
Right, Murali, just let me know if it's going a little too deep. The first question refers to something you said a couple minutes earlier, where you said that there could be a Search AI node inside of GALE. And could that Search AI node be both standalone Search AI as well as Search AI as it exists in XO11?
It will, as it exists in XO11. Because anyway, we have the entire infrastructure of Search AI right there. You would do what you need to do there, and essentially being the specific collection of documents you want to bring in within GALE. And you just say, okay, here is my Search AI node. Once you drop in, all your collections will be available that you have permissions to access. You select the collection you want to, and then that particular node gets executed based on the information that goes into it.
Thank you.
Sure.
A second question is, if you have XO and you're going to invoke a GALE AI somehow, do we have any special way to handle asynchronous execution, or when we say long-running execution in GALE, let's say that took a minute to run inside of GALE, do we have any special provisions to handle
Right.
that?
Within GALE, we have async that we are working on right now. It's already in dev. So when you have a long-term execution, it'll pull any URL you give based on the execution and the progress of the execution. When it's done, it'll say, I'm ready, and you can continue processing of that particular flow. Okay. So now I want to start off with one use case that we worked on for a bank. And essentially, this is about email automation. I'll just give you a brief overview of the flow, and then I'll walk you through the entire product stack of how we end up building it. So what this particular organization does is they process a significant amount of emails on a daily basis. And I'm sure every organization has this particular workflow somewhere or the other within your enterprise vertical. So when you get this, maybe this works or not. I will set my apologies. When you get the emails, essentially what happens, the first thing they do is they process the emails. And there is a bunch of different things that needs to happen beyond that. They identify what kind of information the particular email is talking about by having a category defined. Once you have the category defined, essentially they're trying to figure out, well, how do I process this email? What do I need to do in terms of responding back to the customers, right? Once they identify the category, there are particular scenarios where they have certain business rules. So for example, the customer say, you know what, you charge me for my credit card, I don't want to continue with your bank anymore, and I just want to close the account. So that's a trigger for them. Typically what happens is the flow will say, well, this is an account closure. That's actually right. But from a bank's business rules perspective, they would say, we don't want to really do that. We want to try to go back to the customer and see, is there something that we can do to retain the customer back? So there's some kind of ambiguity involved in certain type of detections of categories. And we have an ambiguity category which actually manages this ambiguity and figures out what it needs to do. And if that is the case, there is a loop that goes in, and then there is a case type detection that needs to happen post that. Then after the case type, there is a bunch of business rules that needs to be applied. Eventually, you have the sentiment and the entity extracted. And we wanted to generate a brand new email, but they have this entire regulatory processes for which they have to choose from an existing email that's been vetted by the legal, whatever. So we will go into a template of repository of emails, pull out the right kind of email based on that particular piece of information, and then we send the email out to the customer. We also raise a ticket in the ticketing system saying this is the kind of email that came in, this is what we have done, and hence here is the ticket. That's the process they do today. So give and take, they process about 6,000 emails a day. So approximately it takes anywhere between 9 to 12 minutes to process per email with all of these steps involved. So if you think about 6,000 emails and 9 to 10, even average of 10 minutes a day, you're thinking about 1,000 hours spent on processing these emails. When we've got this built on GALE as a part of experimentation, pretty much the entire operations of this was automated with GALE. And what I want to do is walk you through, as I talk about the product itself, I want to walk you through step by step about different features of the product, plus how we went about achieving this. Okay, I'm going to switch real time now. Okay, you are seeing what I'm seeing, yeah? Cool. Is that visible? Better? Okay. All right. How many of you guys have gone to the booth and just saw the preview of GALE at all? Okay, so you probably know about GALE a lot more than what I can explain right now. But broadly, GALE has 4 broad sections, if you will. Agents, that's where you build the agents. Then there are models. This is where you bring in, configure your models. The playground is the area where you experiment with prompts and models to figure out what works well. And there is a data section, which is very early stage right now. We enable you to bring in data for fine tuning. We also enable you to bring in data for you to create prompt experimentation. But eventually, the data studio itself is something we'll continue to build, and we'll expand on that for multiple different things. One of them being, we will enable you to create synthetic data that will help you do the fine-tuning of the models better, especially when you have limitations in terms of the data, or you don't want to use the actual data and you want to sanitize it. You can give a sample of the data set and then say, this is the schema I want you to use to generate a large data, and that the models and the entire experience of the data studio will help you generate a large data set. Given 100, you may generate 1,000 or 10,000. So I'll start with the playground, and let's keep the email automation as an example as we go through it. So one of the challenges we had is about identifying categories. So when you experiment with these large language models that are out of the box, let's say GPT 3.5, Cloud, whatever, you can prompt them, you can instruct them, and you can tell them as much as you can, saying, do not tell me anything but this. They will follow a couple of times, and then the third time, like a teenager, they would say, I will not do it, and it'll give you something, oh, here is something I don't want you to tell, but I'm telling you anyway. So those things happen, and when you start thinking about it, especially when you're starting to build a workflow, you want to understand exactly the kind of information. For example, if it's a category, you just want a category. You don't want any stories around the category, because the next step depends on what category it is, and you're trying to figure out how do you actually process the rest of the steps. So with that, we experimented with a few things. I mean, just briefly, this is the playground. And when you come in here, you could put in, you can create a new experiment. And when you go into an experiment, essentially there is a simple mode and there is an advanced mode. There are a few things, let me briefly explain. Now we have a template set here, but this template set is very basic that we have. There is going to be a comprehensive template set that's going to come in, which is going to have information of all different type of prompts. So what we have done here is we have created about 70 different type of prompts for various different type of categories that goes into the detail of what kind of prompt you need, how do you actually make sure that you instruct the model to get the right kind of information. So for example, let's take summarization. And we have a detailed explanation about what these prompt needs to do, where the information needs to do, what model actually works very well for this. And we start to experiment with open source foundational models as well, and that will also be included here to say, well, this makes sense, not make sense. So what you see here is a bunch of different prompts. As I said, there is a significant long list of these. And we are trying to figure out all common use cases that we've been looking into, and typically that's there within the organization, and make sure you have a starting point. That these prompts by no means are the best, but they are a very, very good starting point based on what we've been experimenting with. So that will be available in the product as part of the template, and we're also creating what we call a prompt hub, where you can pick these prompts based on the use case and start applying and experimenting with them directly. So then there is simple mode. In the simple mode, you get one prompt, and you can have multiple models. So for example, I can say GPT 3.5. I can have two GPT 3.5s, but I can play around with the parameters. I can say, well, you know what, make this a temperature 0, means be exactly the same time, no creativity, or make it temperature 1, you go crazy as much as you want to and generate any new content if you want to. And you can create all of these, and you provide a prompt, and then you say, let's go. And there are a few things that are happening here. One is obviously the prompts are getting generated, and the responses are getting generated based on the model. And second, what's happening here as well is you get a piece of information. For example, if you look at not only what the response is going to be, you'll also see how many tokens this particular prompt consumed, the input and the output. That's very important for you to figure out what the cost is going to be approximately. You can also look at the latency. Did it perform well? Did it not perform well? What happened? And depending on the use case, you might want to look at and say, do I want a sub-second latency? Do I want a latency that's longer than 2 seconds? Am I okay with that? So you'll be able to do this comparison. What's in works right now is we are trying to come up with, in fact, very soon, by the time we go GA, you will have this. Every response that's generated by these models, we will relatively evaluate them. And that evaluation will be done by another model, which will say, out of the 3 responses you generated, the second one is better than the third, and the third one is better than the first. And it gives you reasons of why. And you can define how you want the model to evaluate those responses as well. So for example, you can say, okay, if I'm testing this prompt, here is my golden answer. Evaluate all the responses based on this golden answer. Then there is no relative comparison. There is a comparison against the golden answer. But if there is no golden answer, then we will say, okay, out of the 3 models, probably the second one is the best. You pick that for this particular scenario. So that will come in, and alongside these, you'll also see a rating of from 0 to 10 or 0 to 5, and it'll explain why that particular rating is. I'll show you a flow where we have actually built the agent flow to showcase that kind of a rating and what happens in a bit. But there we have used we used a combination of models to generate. One model is generating the output, other model is evaluating the output, and the first model is taking the input from the evaluation, redoing the output from the first experiment. But those can be commercial models. We are also support some of the open source fine-tuned models internally what we are doing, and there are some classic models that are available in the market already that is designed and fine-tuned to do such a job. We are going to bring that in and start supporting that within the platform. Now, that's the simple mode. Coming back to the example, this is the advanced mode. In the advanced mode, you get a lot more different options. In the simple mode, it's one prompt, multiple models. In the advanced mode, it's multiple prompts, multiple models. And this is important when you want to run a batch of different prompts that you have, and you want to experiment and see. Obviously, if you experiment with one prompt and see comparison with 3 models, you get an idea, but you want to take a look at probably a longer list and see, well, how does the average latency work? How does the average accuracy work? What is the response time in terms of the tokens consumption, in terms of the tokens taken, average, both input and output, and also the rating in the future. So what's happening here is you have a system prompt. I mean, these are, I'm sure all of you guys know what each one of these mean. And then we have a long prompt here that we've enabled. So let me show you what's happening. So first is we've uploaded a CSV. Now, in the CSV, there is a bunch of different prompts. We have about 5 as an example. Now, this CSV has various different columns. When you upload them, now the way you actually create multiple prompts and multiple models is you obviously select the model. That's great. And then now you can choose any of the columns within the CSV as your variable. So once you select any of the columns within the CSV as your variable, now each one of those rows become a prompt specifically, and they're run against every model that you have chosen. Now, explaining the scenario of the email automation for the bank, and what we were looking for is to identify the category. Now, we prompted pretty much in every different model and said, okay, this is the prompt we want to apply. Now, Claude came up with it. He said, okay, here is the response. Based on that, what all we are trying to figure out is what type of category this particular email is. Now, it's going about explaining everything, and we can't process that in real time. So we said, okay, that's cool. That's not working. Now, 3.5 did a decent job. It's much more concise than what 2.1 is, but still not. You can see that sometimes it says, yeah, I know the intent. I'm going to tell you what it is, but I'm also going to tell you that it is an intent. That's irrelevant information because that's what we are asking the model to tell, but it's going to include that anyway. But that's right, foreclosure letter, it's getting that little more concise, but this one is still long and lengthy, what we can't process. Now, in this one, it not only tells the intent, it also is now telling you the category. We didn't ask for that, but it's I'm going to tell you the category any which way. So you can see that when we start using these models, when we start experimenting with it, we realize that what we want precisely is not really happening. The models are giving you, I mean, it's not that it's bad. If your human is reading it, they'll understand exactly what to extract out of that. But if you want to construct that in a workflow, then it becomes quite challenging about how do I create any kind of intelligence behind this that can extract out exactly this piece of information. Now, then we went about fine-tuning the model, and I wanted to show you what happens when you use a fine-tuned model. Now here, this model was trained on a bunch of data where we wanted to make sure that it exactly gets out what we're looking for. And once you give that, our model responds back with exactly that and nothing else. Now, this is useful because now it's predictable output, and I know I can actually use this in the workflow, and based on this piece of information, I can decide what I want to do in the next step. So this experimentation, and a lot of that needs to be done before you can actually construct any kind of flow. Yes, sir.
A couple of questions here, if you don't mind. So firstly is, does this experiment support few-shot prompt?
Experiment support?
How do we inject a few-shot example into the prompt?
Good question. Here.
Okay. Here are the example. Second, the question is, this is a classification task, right? Using GenAI model to do classification might be an overkill. Does GALE support the traditional ML training?
Right now, we support only transform models, but we will be supporting traditional AI models, whether it's classification, prediction models, etc., because we know that organizations have spent time building these models already in one form or the other, and they will make a lot of sense when you start constructing these workflows. So you will have those support very soon.
I didn't quite understand where that intent that you showed came to come from.
You mean this one?
Yes, yes.
So this is actually a model. Oh, okay. So each one of these are a model, right? So I've selected this. Essentially, I could show you another model. Just like the way I showed you what you can come in. These models have been configured already. So let me go back a step. We have all the external models configured in the platform that we want to use. So in here, right from Claude all the way to GPT-4, we have foundational models that are already configured as well. I mean, so since I'm here, let me talk about this, and then I'll go back to the prompt engineering. So in the models, any external model we support, you can configure that by just one click. And here you can say, I want to add a model. You can do an easy integration. That means we already have direct access to most of these models. You can select the OpenAI, you can select OpenAI on Azure, so on and so forth. Or you can do a custom integration, which means that you can bring your own custom model via API in here, and that becomes a foundational model as well, especially if you already have an existing model that's within your organization. Open source models, we support more than 30 open source models right now, and it's a one-click deployment. The moment you choose a particular model, it will ask you what the model deployment name to be, and then it will ask you for the parameters. These are default parameters upon which it's going to be deployed, but during the inference time, you can change these parameters if you want to, and then it asks you for which hardware you want to actually host this on. And once you do that, and if you say, okay, deploy this, you can deploy the model. One of the things we do is every model has its own TNCs. So we provide that specific model's terms and conditions here for you to read and accept them, because we really do not own the model, although we host the model. Most of these open source models have their own licensing, and every one of them are coming up with something creative in terms of how they define the licenses. So we will share the licenses with you, and then you have to figure out whether you accept the terms or not. Once you deploy those models, they are available here for inferencing. And then comes the fine-tuned model. This is where you go through the process of fine-tuning a specific model. And the fine-tuning process is actually a pretty simple process. You have to figure out what the model name is and whatever you want to say. And then you start with the base model. This is where you actually choose which base model you want to use to fine-tune on top of it. You define certain parameters for you to train that particular model, including the number of epochs and the batches that you want to actually train it on. Then this is where you bring in your data set. I mean, one of the places where you would spend a significant amount of time for fine-tuning is actually curating the data set. The fine-tuning process is extremely simple within GALE, but it's the amount of time for you to get the 1,500 or 2,000 data points that are necessary for you to fine-tune the model. Once you have the model data that you need to fine-tune, then you can define the data set. You can also define how much of that needs to be used for evaluation and training. You can also upload a test data set. Once the model is fine-tuned, the fine-tuned model is applied on top of this test data set, and it will show you the results of what the output is. We already have the RL, reinforcement learning thing, coming into prod. We are right now testing that. There are two approaches we're going to take for reinforcement learning. One is AI-driven feedback. So once your model gets trained, then the output of the model can be evaluated with any good model that you want to use. So for example, you fine-tune a model, you want to use Claude 3 or GPT-4, and say, you evaluate the output of this model based on the prompt I've given, and it'll give you a rating. That'll be useful for you to go back and see how your model is comparing to the best model in the industry. Yeah.
So I think for many of our companies, we're concerned maybe about repeatability of the model, getting the same results, and if it's an open source model, we don't know what's going to happen with it. And so is this fine-tuning functionality, is that the same as making a model private, or is that a separate topic in itself?
So if you use an open source model and host it by yourself, by definition, it's private. So it does not live your ecosystem. Fine-tuning is, I was showing the example earlier where the general purpose models are telling you some stuff, but you wanted an exact piece of information that you want to get out. So in that particular scenario, you fine-tune a model to make sure that it's getting the better accuracy and the right kind of output for yourself. But everything you host within GALE is private by default. It's either on our cloud or in a private cloud or on-prem. So that's, yeah, of course.
So here's two questions for you. So that model, I think you maybe it's still getting there, but that model that returned the intent so nicely, that was a fine-tuned model.
Correct.
And then secondly, when you deploy the model, so obviously when I deploy an open source model, it's my private model in my workspace.
Correct.
So per definition, it's private for me. But when you deploy, you could select hardware. So obviously there's speed and cost implications connected to selecting
That's
hardware.
Right. Yeah. So depending on what your use case is, what's your inferencing requirements, you may want to choose the right kind of hardware. But what we definitely do is, based on the model parameters, we define the base hardware that's necessary for you to run that particular model. And beyond that, you can decide if you want a higher hardware because you have a lot more inferencing happening on it. I was talking about reinforcement learning. So once you have the AI feedback, we're also providing human feedback reinforcement learning. And we enable that with two different approaches. One is classification, which means you can actually define the parameters upon which you want to evaluate the model. And once the model tuning is done, you can send that to a batch of humans. I say humans, us, to a bunch of us, and basically, and you can ask them to evaluate the model based on the parameters, and they can go back and say, well, this is doing well on this parameter, this is doing well on this parameter, and that information is useful for you to go back and say what you need to do with the training of the model. The second is ranking. So once you fine-tune a model, and you say, I want to do a ranking of this with a bunch of users who can actually take a look at this, we generate 5 different outputs for a given prompt, and they can rank the 5 outputs and saying the third one is the best output, and that re-ranking can help you go back and say, you know what, is there something I need to tweak with the data for me to fine-tune it again? Or you can also use that to basically go back and do the reinforcement learning of the model itself. One of the things we are doing behind the scenes that we will enable you directly to do while you're deploying the both fine-tuning as the open source model is ability for you to quantize the models. So we're doing that behind the scenes right now, but we will enable you to do different type of quantization, and that can be from 16-bit to 1-bit to 4-bit, whatever you want to. If you are willing to compromise with the accuracy a little to increase to make the performance of the model better, we enable that directly during the deployment stage, and you'll be able to make that happen. So our question. Hi, David. We could use the AI models to evaluate that as well. Yeah, we could. I mean, that's a good thought. Look, I think what we realized was that if you can evaluate the output of the model that's been fine-tuned with a powerful model, by default, you get a lot of different information from there. But if you want to just re-rank that with another model, that's possible too. But the re-ranking makes sense when somebody is manually reading it and say, you know what, because the nuances, especially specific to domains, make sense for the person who's actually been in part of the domain, understand what they're looking into, and they re-rank that. But possible with the AI. Yeah.
So, Murali, there's a lot of discussion, say, on the net of like how you might fine-tune like Llama 2, for instance, using these quantization approaches that you're talking about. So, will we be able to take like a Llama 2 model and fine-tune
Llama 2?
Yeah.
We have done a lot of Llama 2 fine-tuning already, and the answer is yes. We support Llama 2 out of the box. We support 7, 13, and 70 billion models. And you can take that and fine-tune them. We have done some fine-tuning of Llama 2 models as well. But even we started with Llama 2, to be honest with you, and now we are becoming much more comfortable with Mistral models. Their performance is a lot better than Llama. But obviously, it depends on the use case and what they're trying to do. Okay, so, and then you go, one of the other things we also do is we enable you to connect to weights and biases directly, especially if that's the platform you're using for evaluating model fine-tuning and the parameters associated with it within your organization. And if you bring in the weights and biases key, all part of the training will be pushed directly to there, and you can use that particular platform to figure out what happened during the fine-tuning process. And that's pretty much what you have. You'll get a summary of all of this, and if I hit fine-tuning right now, it'll start the process, and let me not do it. We have obviously done significant amount of fine-tuning, various different pieces, and there is 2 models fine-tuning right now, but sorry.
Yeah, a question about the best practice. Let's say we have right now we assuming a case, right? We do a task using GPT-3 25. We have some prompts there. We think those prompts are performing well. We want to fine-tune models. In the fine-tuning process, how do you handle the prompt used in the GPT-3 25? Is that in the input,
Yeah.
or part of the input, or output, or use as a prompt?
I'll show you what the training file looked like for this. So most of the hold on. So in this particular scenario, I was talking about the completion, which we are using as an example in the prompt playground, right? So what here, pretty much what we're saying is all the transform models fine-tuning has an input and an expected output. So we use that and say, you go through this process. When you see this input, this is exactly what I want. So what we are saying is, don't think about anything else beyond this. And if you get this particular prompt, get this output. And we generate a lot of different data points. We have generated, in many scenarios, synthetic data set using GPT-4, using Claude, and say, okay, what we want you to create this kind of agent-bot conversation, generate that. That's when we actually came up with the idea of saying we should enable synthetic data generation directly in the product, and that's what we're working on. So once you have this, so for example here, you have an utterance. And what we're saying is we are essentially training the model when they look at an utterance, and the model has to extract out piece of information from this particular utterance, and this is the kind of completion we want you to do, right? And we go through with thousands of data points here, essentially explaining all different scenarios. And one of the things about when you're fine-tuning is you have to try to balance your data set with both positives and negatives as much as possible, so it can see all possible combinations, and then it will try to maintain the boundaries that you're looking at. So we have gone through this process of fine-tuning a significant amount of data set, and so if you have generated some GPT-3 prompts and you've used that, you can bring that as a part of the fine-tuning process and say, okay, here is the prompt, here is the response, but this response is not what I want to use. You want to edit that response and see exactly what you want to use, update that, and use that as a part of training data. Okay, now going back to the playground. So coming back to your question like half an hour ago. And that's what you see here is the model that we had fine-tuned. And when we were looking at, I think it was your question about the intent, sorry. And so here, what we're doing is we're comparing different models, and how the intent came in is because we had trained the model to identify this kind of an intent, and that model is what I'm using here as an example for it to go back and look at all of these different prompts and say, okay, now I've trained you, get me the output, and let's see how you do.
Still, is there a place that I can specify these are, because still this is like a predictive job, right?
And oh, you mean what kind of prompt you want to write?
Two things basically. Is there a place that I can bring my set of intents and say that these are my set of intents, right? And what combination of model fine tuning and prompt tuning is going to work the best, let's say, in predicting those intents?
So it depends on the use case. Especially in this particular scenario that I'm talking about. So here are the. So let's go through the prompt just so that you understand what's happening, right? We're saying, well, here is the asset. I mean, if you find anything related to these kind of things, which are assets, we want you to include these kind of intents. We are making that as part of the prompt. Because the model understands this as a part of the fine-tuning, when you give these intents, it exactly knows what it has to extract out, and that's what it is doing, right? So that you're providing as part of the prompt. But that you can provide this for a general commercial model as well, and they typically find that information too.
So that should be a part of the prompt.
Correct.
And if I have let's say hundreds of
No, you will not have, I mean, even if you have 100 set of intents, it's the category that you're trying to extract out. So once you tune the model, you will be able to figure out which kind of category that falls into, and that's the type of information that will go into the training of the model. You will not bring in all the 100 kind of intents here. The other approach you could potentially do is you could identify the category and then go about figuring out the second level, saying, well, the top level category has been identified. Now I want to identify a second level category, and you identify that, because typically these hundreds are going to be organized in a hierarchy, and you can say, well, the top level first, and then branch it out to a second level, etc.
Yeah. Actually, I was going to go the opposite path of Platin with this approach.
Huh.
Not going from the hierarchy to Platin to see if the new LLM can help me with that. But it's okay.
I mean, we have to take a look at the specific scenario to understand what you're talking about.
Okay, after.
Yeah, happy to. Okay, so that's the advanced mode. One of the things that I do want to talk about, I think we're just about the first army, is the entire history of prompts. So as you're going about experimenting with prompts, there are a lot of experiments you do. This is very important because it's not going to be right the first time. And as you go through the experimentation, typically what happens is you try to write down a notepad, some kind of Word document saying this worked, that worked, and we face that issue when we're trying to do all of this model experimentation before. But now you just, the moment you generate an output, there is a record in the history. You can travel back in time and figure out what you did, along with a combination of models, what prompt you actually used, what hyperparameters you used to get that particular response, and you can restore that particular state back again. That enables you to say, okay, I tried something like 5 prompts ago. I forgot what it was. Now everything I've tried is not working. I want to go back there. You can travel back in time to make that happen. Then this is, once you have generated these, by the way, you can go back and say, there is my favorite model. This, is that visible? Yeah. When you make a favorite model, essentially you evaluated all of this and say, okay, this is good. This is the model I want to use. You will have the ability to copy this as a node. Remember that when I talk about flow, I'll explain what this actually means. Pretty much when you copy this, you can go into the agent and drop it. The combination of the prompt and the model configurations you've experimented with here gets copied over, so you don't have to rebuild that back in the flow again. So that's broadly about the playground. As I said, we are working on the evaluation framework. That's going to be part of this. We are working on prompt hubs, giving you access to all the prompts I just showed you, about 60, and we'll continue to work on that and expand that library. That will be going to be a part of this as well by around the time of GA. Any questions before I go into the agents?
So I think on the search AI side of it, I can see some resemblance, because in this similar experimentation, is there any roadmap to connect this experimentation to search AI? What I meant by that is, let's say I have 1,000 documents in my repository, and I have a source of ground truth. Let's say my business partners gave me that, okay, hey, 1,000 documents, these are the 50 questions, and these are the ground answers. Now, within the search AI, I know search AI also has a prompt that you play, and then you kind of test it. And here it seems like really easy, like you have a prompt and you have upload a CSV. So is there a way we can connect these together so that, I have 1,000 documents uploaded, and my business gave me these 50 questions and 50 golden responses, and this is the prompt. I have the connect to those 1,000 documents, and this is my ground truth. Play the prompt that reads these documents and figures out which model and which prompt is giving me the right answers based on the ground truth.
So if I understand you correctly, obviously you have the entire documents uploaded, chunked, etc. Now, when you extract out the responses, and not just the chunks, but you're also looking at the final answer. And now you're saying if the final answer comes in, we have a golden truth for that final answer. And if I give the particular prompts, I want to be able to cross-compare that. Well, that could be done. In fact, I know there is some roadmap happening within Search AI, especially in terms of prompt experimentation and ability for you to kind of drill down deep into what's happening in terms of retrieval as well. But we can either part of GALE or part of Search AI, we can think about that as a feature that we can add on. Absolutely. No, that's a good input. Thank you. Okay, any other questions? Yeah.
As the number of models explode, of course, experimenting, taking the onus is on us. Is there something that you are going to do which would enable the down select?
So we have an entire team evaluating models. And in fact, right now, when we start uploading models into GALE, we are evaluating those models, and we know they work for certain type of use cases, and they are decently working in most use cases. So that's why we don't have all open source models available on GALE. We carefully go through the process of figuring out which one makes sense. That said, what we're also trying to work on is some kind of a benchmarking that we can start evaluating the models. I mean, we already have certain benchmarking we use internally. We want to make those benchmarking available, so when we actually publish a model, we will tell you what the benchmarking is, alongside the general purpose benchmarking you already have available on Hugging Face. So that's another piece that we are thinking about. Evaluation, I was talking about model evaluation here within the prompt playground. That will be part of the model evaluation for the foundational model as well. So given a particular prompt, you can evaluate multiple foundational models and see which one of them is making sense. All said, this is going to be our perspective. That is the reason why we said you can bring in Hugging Face models directly, because we know you may have a different point of view about how you want to evaluate. One of the things we are trying to get to is, as we come through the evaluation model within the prompt playground, is give you the ability to define the evaluation metrics. Once you define those rubrics, then we will use that to analyze the models and give you a rating based on those. Then not only can you look at what we have done in terms of benchmarking, you can bring your models and benchmark it against the rubrics you define yourself.
So when you're saying you're trying to go into benchmarking, so we have, actually know what's the best model to use. I mean, the current setup at least is still feels very linear. Let's get their own, a little bit early in the process, pick which LLM you're going to use, get the guide key for it, et cetera. So how are you guys approaching differently where obviously I don't want to try to get my keys and everything for each different model. So you're basically saying, well, if you train a few queries, I'm actually going to go back and run through a handful of preferred models before we have to go through that. I'm not sure how I would go back.
So I couldn't hear you completely, but no, you're fine. Well, you're telling me.
Yeah, I was trying to say, like, so today, if I want to use, I have to choose my particular model, then go get my API key, get it all set up, and do that, and then off we go. But if I want to look at evaluating maybe half a dozen preferred models, do I have to go through that each time?
No.
Or is there going to be where I go, okay, here's my few queries, and they'll somehow already identify and benchmark against a handful before I pick a preferred one to go with?
So our benchmarking is based on the models that we are evaluating. That's one. When you come into the platform itself, you have to use the models that you want to use. You have to configure them. You have to say, okay, I want to deploy Falcon, or I want to deploy Llama 2. So you have to enable that deployment, because every instance is your own private instance. We don't share model between instances. Right. So if you want to experiment with certain models, you bring your own and you deploy that within the platform, and that will be very much.
Okay, so your benchmarking is agnostic to what we're doing.
That's right.
Okay, based on benchmarking is the one.
Correct. But when you bring yours, we also enable you to the benchmarking when you're experimenting itself. That's where we will define that ability. Thank you, Kobus. Ability for you to define the rubrics upon which you want to benchmark. So once you bring the models and configure that within the platform, you define what rubrics you want to essentially evaluate these models against. And once you have those, then every model, it's going to be evaluated against the benchmarking parameters.
This is a little bit more commercial question, but I'm assuming that some of these open source models, when you go to the market, they have to be some kind of a commercial license process. That is not going to be covered over GATE. You have to do it by yourself.
Correct.
And you're only going to provide the virtual machine to run and everything.
That's right. So, I mean, we will let you know what the license restrictions for each of the models are. We currently have a full licensing agreement of the model defined there. But one of the feedback I can take from this is also give you a summary of what that license is, especially from a commercial perspective when you're trying to deploy the model, so you understand what it is. But it is, of course, your own risk in terms of evaluating the model licensing and see if you're compatible with your organization's legals.
How do you get the emails to GALE?
So right now, within GALE agents, which I'll go show next, we have what we call an API node. And once you have that, you can pretty much connect to any of your enterprise system. And I'll show you in the email automation example right now. Go with.
So more a comment than a question, but I think once the documentation is ready, it's going to be a huge enabler. I mean, I'm just imagining documentation describing how to fine-tune with data examples and also the experiments in the prompt, in the prompt playground. So I'm just thinking in general, once the documentation is, up to speed for GALE, it's going to be a massive enabler and a piece of education which I don't think currently really exists on how to in detail fine-tune and what the data should look like.
Yes, you're right. I mean, that's where I think we will have more than documentation. We'll actually go through a few video series to explain how we have done historically in terms of fine-tuning. But that process is going to continuously evolve, so we have to continuously evolve these videos. So, do you guys want to take a 5-minute break? Okay, let's do it.